Okay, it looks like a test is coming up again this week on surface area and volume. The stuff is not hard, you just have to know how to do it. The surface area of a solid is basically how much wrapping paper you need to fill to cover up the box, cover up the solid thing. To get the surface area, you add up the areas of every face, and you already have the formulas for area of different shapes, like here, if it's a rectangular prism or a box, basically, each surface is a rectangle, and the area of a rectangle is the base times the height. So if you wanted to get the total surface area of this thing, there are 6 faces. The front and the back is one set of faces, and then the 2 sides, and then the top and the bottom. So if you wanted to get the surface area, you calculate the surface area of the front face, which is 4 times 3, and you have that. And then the surface area of one of the sides, which is 5 times 4, right there, 5 times 4. And then the surface area at the top, which is you go over 3 and you go back 5, so that's 3 times 5. You do that. And then you calculate the total. So the total surface area is 2 of those 3 times 4s, 2 of those 4 times 5s, and 2 of those 3 times 5s. And you just do the math and you add it all up. If you're so lucky that you get a net for the box, now all a net is just a box squished. You take a tea box, you just rip it apart and you flatten it out. You get this shape, basically it's called a net. And if she gives you a picture of a net with all the dimensions, then it's easy to calculate the surface area. Just calculate the surface area of the whole shape, right? So this thing looks like a cross or a T. It's got this middle red section, so you calculate the area of that. And then you got these 2 blue little flaps, so you calculate the areas of those, and you add everything up, and you get the answer. Now notice if she gives you this thing, this big red area, you have to add up. To get the length, you had to add up all the little lengths, like there's a 3 and a 4 and a 3 and a 2, and you have to add all those things up to get 3 and a 4 and a 3 and a 2 to get 12, and then 12 is the length, I guess, and the width would be 3. So that's 12 times 3. That's the big red box is 36, square whatever. And the little boxes here, these are 2 by 4, so that's an 8. 8 times 2 is 16, so you add them up and you get 52 units squared. If you have a triangular net like this, then you just add up all the shapes. You get the area of this red thing, which is length times height, and then you calculate the area of the 2 triangles, which is 1/2 the base times the height. They have to give you all the dimensions. So now volume is actually easier than surface area. To get the volume, you just multiply the 3. If it's a square box, square prism, you just multiply all the dimensions together. It's very easy. In this case, 3 times 4 times 5. But in general, what you're really doing is you're calculating the base area. You have to calculate the base area and you multiply by the height or multiply by the depth. So if they give you like this thing, which is a triangular prism, looks like one of those candy bars that's in the shape of a triangle type thing. You stand this thing up on its triangular surface, and this is the base. The base is this triangle, so the base area is 8 times 5, which is 40 divided by 2, because the area of a triangle is 1/2 the base times the height. And then you multiply by the depth, how high it is or how deep it is, and that is the volume. What is the volume, by the way? The volume is how much water or how much sand you have to put into this box to fill it up. And it's in units of cubic dimensions, like cubic feet, cubic inches, cubic yards, cubic meters. So it's in units cubed. So don't forget to put the units, don't forget not to leave off the units, don't forget to put the units into the answer. That's basically it. Now, she could also give you shapes, areas, and volumes of compound solids or compound shapes, which basically you have two shapes. You have to break it up into 2 shapes that look complicated, or one shape that looks complicated. You have to break it up into simpler shapes. So if you get a thing like this, it looks like an L. I don't know what this would be in real life, but it would be in like an L type thing. You would calculate the volume of the first shape, and then you would calculate the volume of the second shape, and then you add the shapes together. Okay, so that's how you do volume of compound solids if something's made up of something else. Similarly with surface area, you would calculate the surface area of all the shapes. If you have cubes, if these things are cubes, where the length and the height and the width are the same, then it's really, really easy, because in that case, it's just all of these faces have the same area, so it's 6 times the area of one of the faces. And if you are so lucky to have a cube to do the volume, that's really easy, because it's just the base times the height times the these three numbers, 3 times 1 times 5. The base times the length times the width times the height, right? But in a cube, they're all the same. So if a cube had a side length of 3, then it would just be 3 times 3 times 3, right? So if it's a cube, they only have to give you 1 dimension. Okay, so that's the special case of the cube. Okay, good luck, and of course, contact me should any questions arise. Take care. Bye-bye.